Hi, my name is William Delbrueck, and today I'll be talking about the purpose of space telescopes. So, when discussing the purpose of space telescopes, it's important to distinguish kind of three main points. What is a space telescope, different types and uses of these space telescopes, as well as the benefits and problems of using these telescopes. So to start, let's describe what a space telescope really is. So the formal definition is an astronomical telescope that operates in space by remote control to avoid the interference by the Earth's atmosphere. And so these systems are launched into orbit through using a rocket, for instance, Falcon 9 or Falcon Heavy, currently used. And so these will be launched into orbit similar to any other sort of satellite. And the purpose of launching these into orbit is to reduce the distortion of frequency spectrums, electromagnetic radiation, and light pollution from Earth. So with this, it reduces the amount of distortion, so the data is much more accurate and is usable. And so this data from these telescopes is used to observe distant planets, galaxies, and other objects that we see in our universe. And so let's look at maybe the types and uses of these space telescopes. And so one use and one planned use is actually to observe habitable planets and how they are created. And so HabEx, the Habitable Exoplanet Observatory, is a future mission that is possible and that it could be used to look at biosignatures such as water and methane in planets and other galaxies and other solar systems in order to habitat. And so these are also used for investigation of dark matter, which is matter, particles, elements, and forces that are unknown or unexplained to humans. Insight on how the universe came to be, so that's the movement of other galaxies, stars, space clouds, and particles. And then also energy. And so by looking at these signatures, such as the image in the upper right corner of the screen, that can be used to develop information about how energy is created and distributed and the gravitational forces. And those can then be used in the realm of Earth and the Earth's uses for those elements. So there's many benefits and problems, pros and cons of using these space telescopes. So the cons are they are extremely high cost. And when looking at a couple different current missions and future missions, for instance, the Hubble, which has lasted 3 years, is going to be replaced by the James Webb telescope, which is currently around $10 billion in cost. And so on average, they're about $1 billion or more to develop. And so they're extremely costly. There's many different parties involved. There's the developers, there's the contractors, the builders, then there's also the launch pad, and then the maintenance. And another con is the maintenance restrictions. These maintenance problems are very hard to locate and access when they're up in space. Moving on to pros, the data acquisition is very accurate. The data is very unique. You can't get any of these data systems and acquisition of data from anywhere else in the world besides from these telescopes that are orbiting. So in summary, these systems and these space telescopes observe distant planets and galaxies, and they're used to answer questions about gravity, energy, and dark matter. Unparalleled data acquisition compared to any other method that us humans currently have, but this comes at an extremely high cost. And so looking toward the future, these will be used for all sorts of different data acquisition. And thank you for your time. I hope you learned something new and about how scientists learn and gather information about the great unknown.